I know what you're thinking. Have I forgotten to do this slide? Actually, this is the most important slide of this talk. You see, what's on this slide could cost your business millions. And that's what I'm going to talk about. Specifically, I'm going to try to answer 3 questions. Number 1, what are the cybersecurity risks of Gen AI and LLM applications? When I talk about applications here, I talk about software that you build using LLMs, like Luminant that we built. What are the risks of those things? Why is this a hard problem to solve? Why is it not straightforward? And then how we can harness the power of LLMs to use them in a secure way whenever we build software. So let's start from some of the common questions that people ask about Gen AI, specifically about large language models. You see, people come to us and say or ask, is GPT-4 or GPT-4 or whatever secure? Can it produce hallucinations? I mean, before you all said you had hallucinations, maybe toxic answers. Can it be used to attack us? Now, these are important questions, but it is like asking if a knife can be used to harm people. I think if it's a good knife, you know the answer. The answer is always yes. So I think a better question to ask is not whether a knife can be used to harm people, but whether we're using the knife correctly. So if I'm using the knife in the kitchen to cut food, am I using the right techniques to avoid chopping my fingers off? Am I storing the knives correctly so they don't fall on me when I open the cupboard? So we should be asking the same questions when we want to use Gen AI in our applications to build our software. So a way to think about the cyber risk of LLM applications. You start from your large language model. That's kind of like a closed box. What you want to really think about is the use case that you build around it. So you've seen an example of a use case with Luminant. So what kind of problem are you trying to solve? And in solving that problem, what kind of interactions does your language model enabled application have with all those things? Does it have access to documents, knowledge bases? Does it have access to the internet? Can it browse the internet? Importantly, does it have access to APIs? Can it do something on your systems? Which users does it interact with? You see, once you have this picture, you're not asking the question, is GPT-4 secure? No, it isn't. You're asking the question, is the way we're using GPT-4 or whatever other model you want to use in our application secure? And this becomes even more important when you want to use AI or LLM agents. I'm sure you've heard about this trend. We don't just want to use AI to summarize stuff or write text. We want to use it to create agents that can go and, on our behalf, operate on the world, replace humans. Some people want to do that. I've got here an example of a company called Cognition. It's a startup. They have developed, or they claim they're developing, a completely automated LLM-based software developer. So they've taken GPT-4, they've given it access to a software development workstation, IDE, compiler, browser, so it can navigate the internet, GitHub, NPM, so it can download packets, and so on. You give it a prompt, and this thing goes about creating the software for you. Now, from an engineering point of view, this is fantastic. From a security point of view, not so much, because the use case is really dangerous. And I'm going to show you an example of this. Because we've seen this before. People take amazing technology, they put it together, they want to ship it to us as fast as they can. And security always comes last. So I'm going to show you what can happen with these agents if we don't do them correctly. I've picked an example. These are the browser agents. So you can install these agents in your browser. They are connected to ChatGPT or whatever you're using, and they can do things on your behalf on any page. Much simpler than the autonomous software developer, but it's going to show you what could happen. Let me see if I can have this video. So what you see here is me having, obviously, my mailbox open. And on the left side, I have installed something called Taxi AI. I have installed this plugin in my browser. It's just an extension. And this connects the pages that are on the screen with GPT-4. So I can go in that prompt and tell it to do anything. For example, open and read my emails. Maybe I can ask it to summarize them. Now the agent looks at the page and can click on things. You probably see the clicks, can read anything on the page and do whatever I'm asking it to do. So that's cool, but what could an attacker do with this? Put yourself in the shoes of the attacker. Imagine you want to exfiltrate confidential information from the user's mailbox. So a user is using this Gen AI solution. So an attacker could send an email like that one. Hey, John, we haven't spoken in ages. And then they can attach, at the end of the email, a prompt. That's a new set of instruction which tells the language model to stop doing what's been instructed to do, go in the user's mailbox, and read confidential data and send it to the attacker. I've made that blank, so it's not obvious that it's there. So the attacker sends that email, and it's now in the user's mailbox. The user asks Taxi AI to go about and do something in their mailbox, and Taxi AI thinks about it and says, okay, I need to read your emails, so I'm going to go and click on the first email. See, I should click on the first email. As soon as it does that, that blank part there, which is the prompt that we added, enters ChatGPT space, and now the agent is operating on behalf of the attacker. So now the agent starts doing what the attacker wants, creates an email, sends that email to the attacker with the bank code that it has seen in the mailbox. So that's what could happen if you use AI agents that haven't been built with security in mind. So specifically, the problem we have is not a simple problem with language models. You see, the way that they work, you give it a prompt, and obviously you are mixing inside that prompt, so the red part that you see there, in this case, is the emails which are in the user's mailbox. The language model really struggles to differentiate the prompt, the instruction it's being given, and the operation and the data on which those instructions should operate. That's a problem. Because in natural language, there is no like parsing, there are no syntax trees, no clear separation, there is a lot of ambiguity. The way that I picture this and why this is a hard problem, those of you that know a little bit how language models work. So the space of operation of a language model, so the amount of content or that it could potentially generate is 50,000 to the power of 100,000. What do I mean? A language model, every time it generates a word, it picks that word from a dictionary of around 50,000 words if you're using GPT-4. So at every step, it gets all those words, it picks one based on a probability distribution, and then it does the next step, it picks the other one, and so on, until it reaches the end of what it wants to tell you. Now, that means that if the context of your language model is 100,000 tokens and the vocabulary is 50,000 tokens, you have 50,000 to the power of 100,000, which is a number I can't pronounce, but it's as big as this. Bigger than this. of that space, this is how much we control. So reinforcement learning from human feedback, the thing that we do to align language models is this big compared to the full space of generations. Which means that if you prompt a language model in an expected way, you are going to get an answer in that green part. The problem is that the attacker is not going to prompt the LLM in an expected way. It's got all the remainder of that huge universe to play with. They can come up with random strings, anything they want to try and drive those distributions. So this makes the problem of deploying LLM applications in production really hard whenever they encounter that malicious input. How do we do it then? How is it that we can ship something like Luminant to you if the technology we're using has this fundamental issue? Well, the game is to try and push the attacker as much as possible to that green area, reducing the space of operation of the attacker. And the way we do that is not simple. Here I've got the battle-tested way or ways that companies like us and our clients are using in order to make sure that they can ship secure LLM applications to you. The starting point here, the LLM is untrusted. Large language models, as they are today, they are completely untrusted. You cannot really expect them to do any reasoning that they have not been exposed to in the training data. So from these, any input to the language model needs to be validated. So if you take whatever the attacker can provide, you are going to validate that input. And there are many ways of doing that. I won't go into the details of that, but a few things to take away is that you want to use classifiers or other language models to check that the input is what you are expecting for that particular use case. And then you want to use prompt engineering to try and separate the instructions from the data. This can't be 100% accurate, but you can really help the model distinguish what is an instruction from what the data are. You do this on the input, and then you also do this on the output. You take every output of the model, and before showing it to the user, you look through it. You make sure that it doesn't contain anything it shouldn't contain, and you vet it as much as you can. And finally, if you are giving the model agency, if you are allowing the model, like we saw, to go and do things on your behalf, you are going to perform access control. You don't want to give the model access to anything it shouldn't have access to. You want to check every single operation. And in the case of things like taxi AI, or even worse, an autonomous software developer, you want to make sure to have a human in the loop. You want to analyze the action plan and approve it. You want to make sure that whatever the LLM has come up with actually makes sense and somebody takes responsibility before you allow the LLM to go and do that. So that was the most important slide of this talk. And if you're interested more into this, you can scan the QR code and you find more about that security kind of canvas that we showed at the end and a lot of the research that we've done in the area. We also have the consulting booth down there. You find me and the other consultants. So if you have questions, you want to learn more about this, just come and talk to us. Again, we are just down there. Thank you very much.